Hello students, and welcome to the first of 10 short videos on the review part of our Calculus 1 course. We're going to start today with rules of exponents because these rules are truly at the heart of algebra, and as some of you may know, algebra is really at the heart of calculus. So without any further ado, the first of the 9 rules on the agenda today, x to the a times x to the b. You certainly remember that this is x to the a plus b. X to the a over x to the b, we subtract x to the a minus b. And x to the a to the b, well, when the exponents are next to each other like this, we multiply them. Little example to illustrate, starting with the numerator, x to the 3 to the 2. What's the rule here? We got to multiply the two exponents, so 3 times 2, y8, x4. And downstairs, y is the same thing as y to the 1, we know that. That's x to the 8. And here we go again with the same rule, y to the 2 to the power of 3 is y to the 2 times 3. So what do we got? X to the 6, y to the 8, x to the 4, y1, x8, y6. Now, let's take care of those guys that are next to each other on each of the numerator and denominator. X to the 6 times x to the 4, x to the 6 plus 4. Downstairs, y to the 1 times y to the 6 is y to the 1 plus 6. And of course, now we can simplify. X to the 10, y8, x8, y7. So now let's take a look at up, down. That's x to the a over x to the b, so x to the a minus b, so 10 minus 8, times y to the 8 minus 7. Final answer, x squared y to the 1. On to the next 3 rules, which will involve some negative exponents. X to the minus a is known to be the same as 1 over x to the a. Conversely, x to the a is 1 over x to the minus a. And I think we all know that x to the 0 is equal to 1. So let's take a look at the next example, starting with the 1 over a5 in the bracket in the numerator. We can write this as a to the minus 5 times b3 times c to the minus 2. And downstairs, we're just going to rewrite. Now we are going to take a look at our second rule, which allows us to subtract exponents when the terms are superposed like this. So this is a to the minus 5 minus 5. Similarly, that's b3 minus 1. And that is c to the minus 2 minus 4. Minus 5 minus 5, that's minus 5 plus 5, that's a to the 0. b4, not after, haha, and c to the minus 6. So that's 1, b4, and I'm going to write c to the minus 6 as 1 over c to the 6, simply because I don't want my final answer to have any negative exponents in them. That's an old calculus trick. If you can avoid negative exponents later on in the course, you will actually be better off. So answers without negative exponents. Finally, we get b4 over c6. On to the last 3 rules of this short video. Multiplication, x times y, all to the a. That's, of course, x to the a, y to the a. Which actually brings me to a little remark. What if it's not a times, but a plus? Do you think that x plus y to the a is the same as x to the a plus y to the a? Should I put an equal sign here? No, the plus or the minus does not work for distributing the exponent a onto the variable, so we can't do that. Rule 8, x over y to the a. Aha, yeah, you can distribute the exponents for multiplication. You can also distribute the exponent for division. Here's a rule that we don't necessarily remember, all of us. X to the a over b, that's the same thing as the bth root of x to the power of a. So let's take a look at that and see what we can use to solve the following problem. I have some roots in here, so perhaps I should take care of that first. Square root of z in the numerator. That's like square root of z. Same thing as square root with a 2 and z to the 1. So that's really like w to the minus 2/3 times z to the 1/2 all over z to the 1/4. And here we go again. That's the cube root of w squared. So that's w to the 2/3 all to the power of 6. I got a couple of little scribbles here that found a way to my pad, so we get rid of them. Good, so gone with it. Allez, allez. So this is what are we going to do now? We are going to take care of the inside of the bracket in the following way. Minus 2/3 is the new exponent of w times z to the 1/2 minus 1/4 all to the 6. So that's w to the, what's minus 2/3? Minus 2/3. Minus 4/3. And 1/2 minus 1/4 is 1/4. Now, I'll take the 6 and I will multiply it with each exponent, right? Because x to the a to the b is x to the ab. So 1/4 times 6 for the z. Okay, minus 4/3 times 6 is minus 24 over 3. As this z is to the power of 6 over 4. That would be w to the minus 24 over 3 is minus 8. And that is z to the 3 over 2. Once again, negative exponent, bring it down. And I have now the following expression as a potential final answer. Z to the 3 over 2 divided by W8, which of course can also be written as the square root of Z3 divided also by W8. Both are acceptable and full marks answers. Have one last problem for us to take a look at, and this is the summative example. Let's see how we can sort of solve this. Well, we have a root in the bottom. I suggest we start with that. So x, y to the minus 2, z to the minus 3, all to the minus 3, divided by 4. Okay, the fifth root of x to the 10, that's x to the 10 over 5, y 6, z to the minus 4, to the 1/2. What is this equal to? That is x to the 1 times minus 3, y minus 2 times minus 3, z minus 3 times minus 3. And we're going to do the same in the denominator, 4 to the 1/2. So 10 over 5 is 2, so x to the 2 times 1/2, y to the 6 times 1/2, z to the minus 4 times 1/2. So what do we have here? Bunch of things. X to the minus 3, y to the 6, z to the 9. 4 to the 1/2, that's the square root of 4. You can do that on the calculator. It's equal to 2. 2 times a half is 1. 6 times a half is 3 for the y. And z shall be to the power of minus 2. So, what do I have here? Up, down, I have x to the minus 3 on top and x to the 1 downstairs. So that's going to be x to the minus 3 minus 1. Similarly, y to the 6 minus 3. Z to the 9 minus 2. All over 2. So that's second to last step. X to the minus 4, y 3, z to the 11 over 2. I have a negative exponent. I'm going to bring it down, and I am going to have this as my final answer, which completes the first little video that we did on rules of exponents. So I hope you enjoyed, and we'll move on to the next one.